Okay, here's my video guide for slide 10 and slide 11 in our lesson 531. And remember, the majority of this lesson is just seeing what tools do we have to solve for missing sides and missing angles in various triangles. And what you see kind of throughout this lesson is there's a lot of triangles that we can handle, sort of like E here. When it's a right triangle, we have an angle and a side. We can handle some of these triangles, but you also run into some, like we see here in 9, where you may not be able to do it because we don't have the tools to. So looking at one like 10, it's a unique problem, and what we can really do, the obvious one here, is to solve for our third angle. We can solve for our third angle using the triangle sum theorem. So we know all three angles need to add up to 180. So what I can do here is say that 48 plus 29, that would give me 77. So I got 77 degrees here, which means I only have, well, let's see, I have 180 total degrees. Subtract out the 77 that is already taken up. So 180 minus 77, that leaves me with 103 degrees here for my angle. All right. Now, we also want to see, can we find the missing side lengths here? And so can we find this side length that I could call X, or can I find this side length called Y? And I start thinking about all the tools that I have, and that's sine, cosine, tangent. Those usually help me find side lengths, but those only help me find side lengths of a right triangle. This is not a right triangle, so it puts me in a bind. What else do I know? Pythagorean theorem, that only works in right triangles, and so I'm kind of stuck here. I don't think I can solve for these missing sides right now. But I'm going to come back at the end of the video and show you a method that you actually could solve for these. Okay? But I want to move on to 11 before I do that. And I want to take a look at a triangle where they just give you three angles. And so our goal is, do we have any tools here to solve for what you could call like X, Y, and Z, these three missing sides? And again, I start thinking about all the tools that I have for finding missing sides of triangles, sine, cosine, tangent. But again, those only work on right triangles. And then I think Pythagorean theorem, again, only works on right triangles, so I'm stuck again. And this one, there is no technique. There is no method here to split this up so I can solve for these missing sides. I just don't have enough information. Okay, so I just don't have the tools to solve for something like this. Let's hop back then to 10, and let's see how we could maybe solve for X and Y here. And there's two different things that kind of work into this, and one is this slide 12 where it talks about how Leah comes up with a strategy to solve for a missing side, and what she does is she splits this into two right triangles. And then she has a right triangle that's actually 30, 60, 90, and then she has another one that we can use to solve as well. That's sort of what happens here in slide 10. But again, and it goes back to slide 3 where it talks about one of the discussion points, would it be helpful to subdivide into right triangles? So there was kind of a hint there, kind of a hint at the end. But to put it together here in slide 10 would have been difficult. I did not expect you to do this, but I don't mind showing it here. If you don't want to see it, you could probably turn the video off from here. All right. But what we have is we can not divide it into a right triangle, but we can actually create this into a right triangle by drawing a line straight down, pretty much the height of the triangle straight down, and drawing it across. Okay? Then what I can do is I can say, okay, if that's 103 degrees, I can actually find the supplementary angle here, and the supplementary angle would be 77 degrees. And I can start using this little right triangle to help me solve. The first thing I need to do, oddly enough, is actually solve for the height of this triangle, which I'm going to call Z. Okay? And how I can solve for Z here is I can say, okay, the sine of 48, so the sine of 48 is equal to, or I put that over 1 like I usually do, the sine of 48 over 1 is equal to the opposite over the hypotenuse. Well, the opposite here is my Z, so the opposite is Z, hypotenuse is 5. And so I can do this with my calculator. By cross multiplying, I get 1 times Z, that's Z. And I get the sine of 48 times 5, which is going to be 3.715, or so let's just do 3.72 if I round it. So now I have this height. That's not technically a side of the triangle, you know, because we want the black lines of the triangle here, like x and y. But we can use that z now to help solve for x, right? Because let's look at the right triangle here for the 77 degrees. All right, if I use 77 degrees as my angle, then I could use opposite hypotenuse again, so I can use sine again to solve for x. And so let's see that. All right, so the sine of my 77 now, so we're kind of looking at this smaller right triangle on the right, put that over 1, set it equal to the opposite over the hypotenuse. Well, the opposite is z, it's across from the 77, and we said z is 3.72. And I put that over the hypotenuse, and the hypotenuse is x because it's across from what would be your right angle here. And so 3.72 over x, and again, now I can solve for that missing side length. Cross multiplying, I get 1 times 3.72, which is 3.72, and then I get the sine of 77 times x. Dividing both sides by the sine of 77, I have to use my calculator again, but 3.72 divided by the sine of 77 gives me 3.81, or I could round that to x equals 3.82. All right, so now I solve for x, so I actually did get a missing side of this triangle. It was at 3.82, or if I just round it to 3.8 maybe. Now, I have to try to solve for y. Now, y is tough because what I'm going to do here is I'm going to use the 48-degree angle and the 5 to find the total distance down here. And then what I'm going to do is I'm going to use the 77 degrees and the z to find this distance just from here to here. And then I'm going to subtract total distance minus this kind of imaginary distance on the outside just to be left with y. So let's find that total distance first. The total distance here is going to be, that's the y, or this bottom part from here to here is the adjacent, and 5 is the hypotenuse. So I'm going to do adjacent hypotenuse tells me to do the cosine of 48 over 1. Set that equal to the adjacent, which let's call that whole distance, let's call it r. So this whole distance here from here to here is my r. Adjacent over hypotenuse, which is 5, and I can cross multiply and solve here. 1 times r is r. The cosine of 48 times 5, again using my calculator, that would give me 3.35 if I round it. 3.35 when I round it. Okay, so this whole distance r is 3.35. Let's find this little distance here. We'll change color so we can see it. Let's find this little distance from here to here. And what we're going to do there is we're going to use, let's use the 3.8 so we can use adjacent hypotenuse of this triangle here. And so it's going to be another cosine problem. This time it is the cosine of 77 over 1, and I set it equal to the adjacent, which let's call it w. So we have w over the hypotenuse, which is 3.8. And then we can cross multiply and solve here. 1 times w is w. The cosine of 77 times 3.8. Let's use my calculator. Cosine of 77 times 3.8 gives me 0.85. Now I'm going to subtract w from r, and I'm going to be left with y, because that r is my whole distance, w is just this portion. If we get rid of the w from the whole, we're just left with y, and I should be left with y equaling, r was 3.35 minus the 0.85, and I'm left with 2.5 here. Okay, so that is a very long way. You can see that took me 9 minutes to do that problem to solve for y and these other missing sides. And the goal here is to not do this, because technically I never gave you a problem to kind of prompt this, but I don't mind showing this because this is where we're heading. We're going to find a better method to solve missing sides of these types of triangles. Okay, so hopefully you kind of stayed to the end and saw this whole thing, and hopefully it's helpful. Remember, 10, really you could find that 103-degree angle, and without all this work you could not find the missing sides. 11, we cannot do anything with. 11, we don't have enough tools, we don't have enough information to solve for these 3 missing sides, or even any of those missing sides. hopefully you find the video helpful. If you have any more questions, make sure you reach out and ask.